Hey, welcome back. This is Algebra 2. We're in Chapter 7, Section 2. We're on page 2, and we have this example that's meant to expand our knowledge of exponential decay graphs slightly. So in this case, it's a general thing, and then we have this x minus h. I'm going to immediately put parentheses around that x minus h because that's how you would need to enter it in your calculator to make it come up with the right answer. And then also, hopefully you'll see that this follows the pattern where, in fact, everything in parentheses is kind of the wrong way in a horizontal shift. And then plus k. So, in general, anything like this is going to go to the right h, and it's going to go up k. It's going to go to the right any number that you're subtracting inside the function, which in this case means inside the exponent. It's going to go up any number that you're adding outside the function on the end, basically. That's always been true. So when you see what we're doing here with y equals 2 times 3/5 to the x minus 1 plus 1, hopefully you're bursting, about to scream, I'm going to go right 1, and I'm going to go up 1. And that's great, because that's exactly what's going to happen. The book makes it a little bit slower first. So first, the book suggests you do it without those translations, without the -1 and the +1 business. You can go ahead and you just figure out what's going on here for this simpler equation. So that one goes through 0, 2, because if you plug in 0 into that simpler one, you'll get 0, 2. And so, there you go. And then 1, they messed up their parentheses here, something like that, and then that shouldn't exist, but you get the hang of it. 1, and then it's 6/5, and so 1, 6/5 is there. I'm going to draw our beautiful little graph of exponential decay like that. Our asymptote is right there on the x-axis. Good times. Now, because though the exponent is x minus 1, we are going to go right 1 and up 1. Now, that, that's a thing, I suppose. So you had this point that was 0, 2. You're going to go right 1, and you're going to go up 1. This point that was 1, 6/5, it's going to go right 1, and it's going to go up 1. And then here's the thing everybody likes to try to forget about, but don't do that. Be smart. That asymptote also moves. Now the asymptote is a line, and lines go forever, so moving it right 1 doesn't do anything. But it does move up 1. So the asymptote is actually going to be here now on the line y equals 1. And so now you can drop your curve of, well, that actually kind of bit, so I'm going to try it again. You can drop your curve, there we go. And that blue graph is the correct graph. I suppose they asked us to fill in the points. We can do that easily enough. It's the point 1, 3, and 2, was it 11/5, I think? If you take 6/5 and you go up 1 from that. Yeah. The asymptote is the line. Good times. The asymptote is that blue line that I drew, dashed line. It's a horizontal line, so it's the line y equals 1. It's not on the x-axis anymore. The domain is all real numbers, and the range is y is greater than 1. That's because, well, it's above the asymptote. That's it for example 2. Now, let's move on to the checkpoint. Boom, the first one, graph the function, state the domain and range. All right, good times. So here's what we know. We know the points 0, -2, and we know the points 1, if you stick in 1 times 4/5, or 4/5 to the 1 is 4/5, times -2 is -8/5. That's a negative 1.6 if you're keeping track at home in decimal land instead. So you have the point 0 comma negative 2, zoom, and you have the point 1 comma negative 1.6, zoom. You're going to make yourself an zoom, exponential decay. Now, the asymptote is still on the x-axis, so that hasn't changed. Now, it did flip upside down because a normal exponential decay, zoom, is like that, and it flips to become that, but that just looks gross. I'm going to erase what I just drew. But it was flipped upside down because of the negative part of negative 2. We are asked for the domain and range, so we should probably provide those. The domain, all real numbers. The domain of any exponential graph is all real numbers. The range. Now look at this asymptote business a little bit. The graph sits entirely below the asymptote, and the asymptote is on 0, so the range is y is less than 0. Boom. That's it for the first one. Now, on to the second one. This one's a little more exciting. I'm going to do it the way the book suggested back in example 1, which is to take a moment, step back, and graph 3 times 2/3 to the x. If you do that, that has the points 0, 3 and 1, 2. So I can go over here and I can graph 0, 3. Notice that they changed the scale on you to be annoying. 1, 2, and zoom. Yeah, it didn't look good. Zoom. Yeah, that looks better. Asymptote is, boom, on the x-axis. Good times. But you know what? That wasn't the question. The question was that. Well, take that graph I just did in red, and it goes left 1 because of the plus 1, and then it goes down 3, and that's because of the minus 3 on the end. So each of those points, I'm going to move left 1. Remember, 1 is half of a square here, and down 3, and 3 is 1.5 squares here. So that's our new point. Each one goes left 1 and down 3. And here's the magic thing. The asymptote also goes down 3, which means I have to try to draw an asymptote there, although I realize it should be in blue if I'm going to match my dots. Take that same general shape. Boom. That's it. Domain. All real numbers. Boom. Range. Well, the asymptote is down at negative 3 now, and I want to be all the numbers above negative 3, because all the numbers above the asymptote. So y is greater than negative 3. That's our domain. That's our range. The blue graph is our function. Thank you for watching.